Okay guys, so today we will talk about discontinuity. Okay, I'm drawing two curves here. Say y is equal to fx and y is equal to gx. Now observe that the second curve which I have drawn, y is equal to gx, has a gap or a hole. But the first curve is continuous. Okay, it's more than continuous. So just by the look of it, I can say that y is fx is equal to fx is a continuous curve and y is equal to gx is a discontinuous curve because there is a break or a hole in the curve. Okay, so this is just by the look of it, we can identify whether a function is continuous or discontinuous. But if I have to explain in terms of calculus, how do I explain this? So let's go to the next slide. Okay. Okay, now let's again draw a curve with a hole. That is a discontinuous curve. And we observe that the point of discontinuity occurs at x is equal to 7 or y is equal to 5. Okay, so I'm drawing a curve here. And I make a hole here. Okay, now this hole occurs at when x is equal to 7 and which corresponds to y is equal to 5. Okay. Okay, now if I have to express this function as a limit, I could still say that limit x tends to 7 fx equals 5. Why? Because I'm only bothered about x value being close to 7, not exactly equal to 7. Right? So even though there is a hole at the point 7, I'm still not bothered because the values which are very closer to 7 still exist and the corresponding value of that is 5. Okay. Now let me also make a point at x is equal to 7. Okay, I create a point here at x is equal to 7. Now this corresponds to y is equal to 3. Okay. Now I can say this as f of 7 is equal to 3. Okay. Now note the difference between limit x tends to 7 fx and this f7 which I have written right now. Okay, now let's notice the difference between these two things. Okay. Since I am talking about the value of the function x equals 3, okay, I am no more talking about the limit now, right? So the first and the foremost thing is remove this limit x tends to 7 term. So I'm removing this term, right? Now instead of x, the value of x exactly, I'm putting f as x is equal to 7. So I replace x with 7. Okay, so this becomes f7. And what's the corresponding value of y? That is 3, right? So this becomes f7 is equal to 3. Okay, so this is what I mean by the term f7. Means the value of x at 7, corresponding value of y for x at 7 is 3. Okay. Now observe, if I have to travel along the curve, so I move up the curve, I meet the point or I meet the hole. Now since I cannot travel across the hole, I have to come down, collect this point which is at 3, y is equal to 3, and then again I move up to the hole, and then I continue my journey up the curve. Okay, so basically what we are seeing here is that there is a break of journey at exactly x is equal to 7 or y is equal to 5, right? So in other words, I can say that limit x tends to 7, fx equals 5, and f of 7 equals 3, and these two are not equal, right? So which means limit x tends to 7, fx is not equal to f of 7, which means that the function is discontinuous or there is a break in the curve. right? So in terms of calculus, how do I define this discontinuity? I say limit x tends to 7, f of x is not equal to f of 7, or limit x tends to c, f of x is not equal to f of c, right?